Did you know that the vast majority of Manhattan that you swing through in Insomniac's Spider-Man games is actually procedurally generated? Yep, that's right. The buildings, the shop fronts, the hot dog stands, the NPCs shooting hoops, the traffic, the civilians, and yeah, even the crime is all built using a procedural generation system. Marvel's Spider-Man was the biggest creative challenge that developers Insomniac Games had ever faced. And to help them get the game to market back in 2018, they built a suite of procedural systems that would take on the bulk of the work in crafting the friendly, and sometimes not so friendly, neighborhoods of Manhattan. I'm Tommy Thompson and welcome to Artifacts here on AI in Games. In this episode, we're swinging through the streets of New York to find out just how exactly this procedural pipeline works, and critically, the requirements it needed to satisfy, given it doesn't just create a pretty-looking game world, it's also responsible for ensuring Spider-Man's web-swinging and movement mechanics actually work in moment-to-moment gameplay. To understand the rationale for having this procedural system in place, it's worth taking a moment to highlight the size and scale of New York City in the Spider-Man series. This fictionalized version of the real-world locale is 3 kilometers wide and 6 kilometers long, spanning all 9 districts of Manhattan: Chinatown, the Financial District, Greenwich Village, Hell's Kitchen, Midtown, Central Park, the Upper West Side, Harlem, and the Upper East Side. Plus, on top of all this, there was a dedicated play space for Rikers Island, given that's home to the superhuman prison The Raft that's critical to the storyline. And of course, each district has its own style, be it distinct recognizable buildings, from the likes of the Empire State Building to Madison Square Garden, or Easter eggs for fans, like the Sanctum Sanctorum, the Daily Bugle, or the Avengers Tower. But those aren't the bulk of the city. The final statistics of Spider-Man's Manhattan are actually pretty staggering, with over 8,300 buildings, but also 544 roads, 350 different storefronts, over 1,200 alleys, not to mention all of the events and activities that take place in those spaces. Each of these elements needs to be placed in locations that make sense and feed towards the overall design goals. While Insomniac has many a talented artist, during the 4-year development of the 2018 Spider-Man game, they were also spread across multiple projects, including the likes of the 2016 Ratchet & Clank remake for PS4. It would be simply impossible to build the entire city within that timeframe, even if they weren't working on other titles. Plus, they subsequently rebuilt portions of the city for 2020's Spider-Man Miles Morales, both to reflect changes to the city that had occurred courtesy of the previous game's narrative, but also redecorating it to fit the winter weather and the holiday theme. Not to mention the expansion of the map for 2023's Spider-Man 2. All of this dictated that the team needed some sort of automation to speed up the process. Now, it's worth stating that when I say that New York is built procedurally, I do not mean at runtime. The Manhattan you play the first time you boot up the game is the same as it is the 100th time you play it, even if the map changes slightly to accommodate each game's narrative. There is no procedural engine in the shipped game. Insomniac built a procedural generation workflow into their development process, meaning that the development team would focus on making a simple, blocked-out version of the map that felt fun to move around in, and then the procedural systems would be responsible for implementing their vision and creating the city by placing the buildings and adding all the art assets to the world that art teams had been crafting as modular components. After the city was generated, artists and level designers would go back in and observe the generated environment, make some changes by hand, and then over time finally approve it and lock it all down. But critically, during development, the team mandated that the map had to be playable at all times, so that other parts of the development team could implement features they were working on. So let's explain the workflow for building the city, and then how the procedural systems work to support the developers' needs. As stated already, Spider-Man's Manhattan is a 3 km by 6 km play space, but in Insomniac's proprietary game engine, it's actually a series of tiles. The entire map is broken up into around 700 tiles, each 128 by 128 meters. This allowed art and design teams to isolate and focus on segments of the map, which also worked for the procedural system, given it could focus on generating on individual tiles. In fact, each tile is essentially a JSON representation of all the prefabs, models, textures, and other assets that reflect that region. As we'll see in a second, the procedural generator helped determine this information, meaning it could be saved and then reloaded into the game when needed. As stated by Yosu Benavides, a senior designer on Marvel's Spider-Man, they wanted it to look and feel like a natural city, but also be fun and intuitive for players to navigate across, hence the use of point launches, parkour and wall running. So they started out by building a rough first pass of what the map might look like, using key landmarks to help define it, but also defining metrics for buildings and regions that would help give character, ensuring streets are wide enough to make them fun to swing across, but also standardizing building heights, so you can tell that you're no longer swinging through Hell's Kitchen, you're clearly now in Midtown. As we'll see in a second, all of this was then fed into the procedural systems, so that it could generate everything the designers needed. The designers would then run generation repeatedly to get the desired outputs and edit them to suit. In fact, this workflow meant that the team could still be making adjustments to fundamental layout and structure of the city in the closing months of development, given the procedural tools helped to speed this process up. As noted by David Santiago, a principal technical artist at the studio, the road layout was still being adjusted in January of 2018, less than 9 months prior to the game's launch. Meanwhile, the final edit to the game map was in June, at a time when the game was being locked down for its Gold Master candidate. So now let's dig a little deeper into how this procedural workflow operates. The procedural workflow, which is designed to interface between popular animation software Houdini and Insomniac's game engine, is built into 3 steps: layout, generation, and review. The system could operate on 1 or more tiles at once and respect the constraints applied to it. The algorithm deployed for this process isn't clear, but it's heavily constraint-based, given designers would define metrics for street sizes, curb lengths, building heights, road configurations, city districts, and more, all of which the system had to respect during generation. Phase 1, the initial layout, had level designers carve out the shape of the map, where roads and alleyways are placed, where key buildings will be, and areas that are going to be important mission spaces. Then the procedural system could actually draw in the roads and ensure they all fit together correctly. Buildings are placed as rough structures using simple 3D shapes, if anything to indicate the size, shape, and rough space it may take up. Then it's time for Phase 2, the heavy lifting. The procedural workflow takes the simple building shapes and replaces them with a fully generated and decorated set of buildings. All the while it also generates a lot of additional decoration, such as street lamps, subway entrances, manhole covers, trees, piles of trash, and more. The final phase was polish. While this system could generate tiles quickly, that didn't mean they were ready to ship. Instead, it was used as a first pass to get the bulk of work completed, and allow design and art teams to then work on each tile, make further changes, fix things the generator had got wrong, and ultimately use their skills to make these spaces as interesting as possible. The generation process could take anywhere from 5 to 15 minutes to run on a full tile, depending on the amount of work involved. It could regenerate the entire tile, or areas that designers asked for it to focus on. By comparison, it was estimated that a human would take anywhere from 30 minutes to 4 hours to complete the same workload, hence a huge cost saving, even if the quality wasn't good enough to ship. If needed, the entire city could be rebuilt procedurally overnight, running on a server in the studio and ready for developers to return to the following day. But as we'll see throughout this video, it was more than just building creation. Light and reflection probes could be placed into each area such that the game could calculate in-game lighting correctly. The same for audio occlusion and attenuation. Typically this is done by hand by an environment artist, but the procedural system would figure out strong placements for relevant assets in each tile. Plus, as we'll see in a second, it was a huge impact on Spider-Man's web-swinging mechanics. Note that this process is not used on every single tile, given specific buildings are crafted by hand, and Central Park is treated very much as a separate entity. But while this was a technological marvel, level design was far from a trivial process. The procedural system was continually being updated and improved throughout Spider-Man's 4-year development cycle, be it adding new features or improving quality. But also it took a long time for any one tile on the map to receive sign-off, given missions would change, the needs of the environment would change, or art assets would change, so the team was constantly regenerating the map to try and fit their goals. Now, while we've focused on the placement of art and props, as well as the other critical engine features such as lighting and audio, there is one critical part of all of Insomniac's Spider-Man games that the procedural system is responsible for. It ensures that Spider-Man can actually navigate the city. So let's take a detour from procedural city generation and talk a little bit about how Spider-Man's web swinging works. Insomniac's titles capture perhaps the most critical element of Spider-Man games by having the web swinging feel fluid, engaging, and behave in context of the local environment. While some games have historically avoided this, given the technical complexity of it, all of Insomniac's Spider-Man games require that any webs the players swing from to physically attach to nearby buildings. While it adds some authenticity to the experience, it also creates a huge technical challenge for knowing where Spidey's webs are allowed to connect, not just for regular swinging, but for web zips and point launches as well. Given the complexity of the buildings, in terms of the sheer number of surfaces and edges on them, it would be too computationally expensive for the game to check for available surfaces for webs to connect to on a frame-by-frame basis. There's simply too much geometry in the region, and it's all moving around the player really quickly. It's worth noting, players can achieve a top speed of 68 miles per hour, or 30 meters per second, while swinging around as Spider-Man, and so checking for valid geometry to swing from needs some optimization. And that's where once again the procedural workflow came in handy. Each building in Manhattan is actually covered in an invisible grid of square panels, which is created during the procedural generation process. When Spider-Man initiates a web swing, the game runs a quick series of raycasts to find which panel it should stick the web to. Each panel is scored using a utility function, with higher scores given to tiles that would ensure the resulting web would help maintain the current direction, not require significant input changes with the player, and also based on the ideal range and angle, such that the swing is going to be as smooth and cool looking as possible. Once a panel is selected, the game then looks for an actual point on the building represented by the panel where the web will actually stick to. Note that this isn't used for all web swinging, given there are a lot of unique objects such as cranes, tunnels, bridges and other geometry, where this was placed manually by designers on prefabs. A really good example of this is in Central Park, given the trees don't have any flat surfaces to put the invisible panels onto. But this is just one part of the gameplay requirements of the procedural system. Spidey's movement and navigation is also heavily reliant on recognizing edges to zip around or over. While many of the props, such as water towers and the like, can have that pre-built into them as part of the prefab stored in the engine, the rest of the map is analysed by the generation system when the buildings are constructed, so the game knows of available launch points nearby, which are then highlighted for the player to select in the heat of the moment. In addition to the web swinging, the generative system had other responsibilities for ensuring New York operates as an interesting gameplay space. As mentioned already, the game map is broken up into tiles. Now, to maintain performance, the engine only allows for around 9 tiles to be active at any given time. And given the aforementioned top speed of 68 miles per hour, the game aggressively loads and unloads tiles and all of their assets, such that all of this looks and feels smooth in the moment. This level streaming is achieved courtesy of a level of detailing or LOD system, which is very common in game engines to prioritize rendering jobs based on perceived distance and relevance to the player. In fact, over in the episode of AI in Games all about Spider-Man, I talked about how the civilians use level of detailing to dictate their overall visual fidelity and intelligence. The system prioritizes loading in new tiles based on player trajectory, and even how you're navigating through the city will influence it. If you're on the ground, then the shop fronts and street props are prioritized. Meanwhile, if you're zipping high across the city, then the rooftops are prioritized and the shop fronts will be loaded in a second or so later. In fact, Spider-Man's top speed is capped in-game to ensure that the tile streaming system can keep up. Now, you might have realized this raises an interesting question. If the game is only holding around 9 tiles in memory, how can you see the entirety of the map at any point in time? If I climb up the Empire State Building, I can see everything from Columbia University in Morningside Heights all the way down to Wall Street. So what gives? How does that work? Each tile in the map has a lower than low LOD level, referred to as an imposter, which is an incredibly simple low-poly representation of all art assets on that tile. During generation of the map, the system will generate the imposter for each tile, so when that tile isn't in memory and active in-game, the imposter is being used instead. In fact, the imposters never load out of the game when you're in the open world map. hence ensuring that at any time you can see the entirety of the city, even at a really low quality level. Plus, you'll notice that props shift depending on the time of day or act of each story, notably the third act of Spider-Man after the raft breakout. This is all handled by the procedural engine, given it saves different prop and lighting configurations for different phases of each game's narrative. Now there's still one last thing to cover: how this system also influences the AI characters in the game world. The procedural system is responsible for how civilians spawn, with traffic volumes for NPCs that dictate how densely a pavement can be populated. These are then connected to one another so that civilians know how to cross the road, but also go to specific points to get on the subway or try and hail a cab. But also, there's dozens of fixed activities you'll find civilians doing. These activities are all known as vignettes. There are around 25 different types that exist in the original game, with over 3,000 locations for them to appear, all placed by the procedural system. Similarly, the same approach is applied to the random crimes that pop up on the map. There is again over 3,000 possible locations for 29 different types of crime. Both vignettes and crimes have a number of constraints that dictate whether they spawn, such as the story act, the time of day, level geometry, and much more. Lastly, when roads are spawned, they come with built-in templates that dictate how vehicles can move along them and what traffic that can appear, be it the types of vehicle, traffic density, and whether there are lanes dedicated for parked cars. It's worth saying the navigable space for both traffic and AI continues to change throughout each game, as the events of the story can influence the layout of a given location, be it due to weather, trash, crimes, or Sable security checkpoints. So each tile stores numerous versions of its navigation data, such that traffic, civilians, and enemies know what space is safe for them to move around in during each act of the story. Making games is hard, we all know this, but sometimes we can find ways to automate parts of the process to help handle the sheer volume of content that needs to be created. It's worth saying that Insomniac's games are not an outlier, and there are many other automated processes used by game developers to speed up content creation, and in fact these tools are used in a myriad of different projects, with versions of them used not just across each Spider-Man game, but for other titles at the studio. But when you consider the sheer scale of Spider-Man's New York maps and the overall quality of the playable experience, it speaks to how important it was not just to build the tools to support developers, but craft an iterative process on using and improving said tools to help achieve the overall design goals. Thanks for watching this episode of Artifacts here on AI in Games. Be sure to catch the accompanying episode of the main series all about Marvel's Spider-Man if you haven't already. Artifacts is my new sub-series focused on generative techniques using AI. We still got a lot of ground to cover, but it's great to have this new series in place, meaning I could split up the relevant Spider-Man material, and boy was there a lot of it, across different videos. You might not worry about this sort of thing, but I do. I'm all about the details, so I am. Anyways, please support my work if you can via Patreon, YouTube or Substack, and I'll see you all very soon in the next video.